this is the practice test for the absolute value functions and reciprocal functions. So we're going to go through these questions so that you're prepared for your unit test. So the student made the following statements. The absolute value of a real number is the principal square root of the square of that number. Is that true or false? First of all, who is having trouble trying to decipher what that actually means? Okay, so the principal square root is what? It's the positive square root of the square of the number. So what that means is if I took a number such as -7, it would be the principal square root of the square of that number. So if I took -7 and I squared it, I would get, and when I take the square root of 49, I get 7. So is that true or false? That would be true. So statement number 2, the absolute value of a real number is the distance of the number from 0 on a number line. That would also be true. Because again, if I plot -7 on a number line, it's 7 units away from 0. It doesn't matter if it's on the left side or the right side, it's a distance of 7 units away. The absolute value of a real number can never be negative. That would also be true, because that means the absolute value of -7 equals +7. Or just, actually not +7, it's just 7. So the statements that are correct would be 1, 2, and 3. Okay? Question number 2, the absolute value of a function g of x, which is the absolute value of 5 minus x, can be written as a piecewise function. The piecewise function, which represents g of x, is what? So what I have is I take this absolute value of 5 minus x and I split it up into 2 parts. I have just the 5 minus x, and that occurs whenever this value is greater than or equal to 0. Because whenever 5 minus x is a positive number, I'm okay. It's when 5 minus x is a negative number. Then what I need to do is I need to multiply that statement, that expression, by a negative. So then if I clean all of this up, I get 5 minus x. We simplify this. I move the x to the other side because it's negative. It'll be easier. And I get that x is less than or equal to 5. So if I wanted to, I could rewrite it so that it's
I'm sorry
left
for
to
the
right.
interruption. If Mr. Malloy is in the building, can you please come to the office? Thank you.
With this one, I would get -5 plus x. And in this case, I'd have x, or sorry, this shouldn't be equal to, it should be just greater than. X is, trying to make many steps at once. That way. So it'd be x is greater than 5. So, for example, if I had a number like 7, 5 minus 7 is -2. So then I'd have to multiply it by a negative to get my +2. Whereas if x was -3, I could use this expression right here because x is less than 5. So the piecewise that matches to that one is, which one? That's a -x, that doesn't work. +x, but this one? No. This one, if I rewrote it, this would be my x minus 5. So there's x minus 5 and 5 minus x minus 5, 5 minus x. The difference between it is looking at the inequalities, right? In this 5 minus x, x has to be less than 5, not greater than 5. And the greater than or equal to can be with either one. It just can't be with both. So this statement here matches with that. And then my x minus 5 is this part. It's just the greater than sign. The equal then was with this one and not with that one. So that would be D. Numerical response number 1 asks, what is the value of the following expression? So the absolute value of 7 is 7. The absolute value of negative 6 is 6. Plus, then I've got the cubed root of negative 64, which is negative 4, right? Because it's
negative.
So a negative of a negative 4 would be a positive 4, and the absolute value of my positive 4 would be, so 7 minus 6 plus 4. Is 5. So I'd put 5 in the first box and I'd leave the next 3 blank. So for question number 3, which of the following statements is false? So the absolute value of negative 2x is equal to just 2x if x is less than 0. So think of it this way. If x is a negative number,
Ours says equals negative 2x.
oh yeah, that's a typo on here. Mine says negative 2x too. So if I pick, just think of a number that's less than 0, like negative 3. Negative 2 times negative 3 would be equal to, and the absolute value of 6 would be 6. Negative 2 times negative 3 would equal 6 as well. So are the two sides equal to each other? Yes. So this is true. The absolute value of 6 minus 7x equals negative 6 plus 7x. So that's taking that and multiplying it by a negative, which I would do if this was less than 0, if it was a negative value. Because if this was a negative, when I multiply it by a negative, I get that positive. So then if I was to solve for x, I would get x is greater than 6/7. And it could be equal to. So x is greater than or equal to 6/7. Is that true? Yes. Okay. With this one here, 5 minus x equals 5 minus x. So that's just removing the absolute value bars, which would work when this statement is positive. So that would be when 5 minus x is greater than 0. And so if I solve for x, what I get is x is less than 5, not greater than 5. There's my false statement. And I can double check D just to make sure. 4x plus 3 equals, or the absolute value equals 4x plus 3. This would happen if 4x plus 3 was greater than or equal to 0. So I'd move the 3 over this time. It would become negative. And then I would divide by 4. And I get that x is greater than or equal to negative 3/4, which is true. So C becomes my false statement. So question number 4 says, which of the following is a root, which means which of the following is a solution to 3x minus 1 equals negative 5. So there are 2 ways that you could do this. You could solve this algebraically, or you could actually take these 3 numbers and put them into the equation and just solve and see which one works. If we did this the algebraic way, that would be removing the absolute value and solving, and I get 3x equals negative 4, x equals negative 4/3, but I still need to put that into the equation. I still need to check if x equaling negative 4/3 works. So if I take 3 and I multiply it by negative 4/3, what do I get? And what's negative 4 minus 1? And what's the absolute value of negative 5? And does that equal the right-hand side? No. So this is no longer a viable solution. And then with the other one, it would be taking the negative. So that would be negative 3x minus 1 equals negative 5. So negative 3x plus 1 equals negative 5. Subtract by 1, divide by negative 3. We get that x equals 2. Again, I have to go and check this. So 3 times 2 is 6. And 6 minus 1 is 5. And the absolute value of 5 is? Which, again, does not equal the right-hand side. And 3 is not actually a solution to this equation. So 2 is not a root. Negative 4/3 is not a root. And negative 3, when we did our algebraic, didn't actually even come up. So it's not a root, which means there are no solutions. The other way that you could have done this is you could have actually graphed it. y1 equals the absolute value of 3x minus 1, y2 equals 5, and look for an intersection point.
Doesn't the absolute value always have to be positive too? So wouldn't you know that none of them would work?
Yep.
Just
Okay, question number 5. The complete solution to 12 minus the absolute value of x is what? So how could you do this one?
can you move the absolute value over to the other side, make it positive, and then move the 9 over, and just rearrange it that way?
You
And do
could.
a positive negative.
Yeah. So if I did that, 12 minus 9 equals the absolute value of x. So the absolute value of what equals 3? So what could x equal? 3 or negative 3. And again, I could have done this graphically by finding intersection points. I could have taken the solutions, because really there was only 2 solutions to check. 12 minus 3 is 9. 12 minus the absolute value of negative 3, which is a positive 3, also equals 9. Okay, question number 2 for numerical response. The equation, the absolute value of x minus 2 equals x squared minus 5 has 2 solutions. Gavin determines the solutions using his graphing calculator and gets them as being p and q. And then you're asked to find what the absolute value of the product of p and q would be. So you would need to take your graphing calculators out. So to get that absolute value of x minus 2, it's math, and then over to number, and it's ABS. And depending on your calculator, it just might put ABS open bracket, or it might change it into the bars. So there's my x minus 2. Oh, maybe I should. Minus 2. And then x squared minus 5. If I graph this on a standard window, zoom 6. So there are my 2 intersection points, so I can find each of them. So second calc intersect. So I get this first one, which is a decimal. It's not a nice decimal. So when I go to write this in, I'm going to include as many decimal places as I can. 2582. And then I do the same thing, finding the other intersection point, which is 2.302 775, and I multiply those two numbers together, which gives me negative 7.3517. So the absolute value of that would be a positive 7.35, which to the nearest tenth would become 7 4/10. Okay. Question number 6 says, which of the following functions is the absolute value of the function identical to the original function? So really, in answering this question, ask yourself which one of these 4 graphs only occurs in the positive y-axis. So if I think of 2x, or think of what happens if I have a negative x value. If I have a negative x value, this is going to become a negative, which when I take the absolute value would become a positive. So they would no longer be the same. In my table of values, so if in my table of values I had f of x, and I had the absolute value of f of x, what I'm looking for is if I have a negative f of x value, when I take the absolute value, I'm going to get a positive answer. So when do I get these negative f of x values? Well, whenever x is negative, I'm going to have a negative. I can't have that. In this one right here, if x is equal to 1, I get a negative 2, which then when I take the absolute value gives me a positive 2. So I would have 2 different values. So again, the graphs are not going to be identical. And in this one, I'm multiplying the whole thing by a negative. So right there, chances are it's probably not going to be identical, because when I take the absolute value of this, it now becomes a positive. So that's not going to work, which by default leaves me with C. But if I look more closely at C, no matter what my x value is, when I square it, what happens to it? It's going to become positive, which will stay positive when I multiply it by a positive 2. And again, you could have, if you needed to or if you had the time, you could have actually graphed all 4 of these. F of x equals 2x and then absolute value of 2x and looked at the graphs. Question number 7. If a graph of y equals f of x passes through the following points, then the graph of y equals the absolute value of f of x must pass through which points? So when I take a function and I take its absolute value, what coordinate is changing? Do they both change, or does one change? So think back to the last example. What changed in my function? The x or the y? Nope. If I look at this one, let x be equal, so my x should have gone up here. So if x equals negative 2, actually I like negative 3 better. If x equals negative 3 and I put it into here, I get a, that's probably not a good example. We'll put it in this one. It's better. If x equals negative 3, f of x would equal negative 6, the absolute value of which would equal positive 6. So in this graph here, what is changing is the y coordinate, not the x. The input stays the same. It's the output that changes because I've changed what happens to that output by taking the absolute value. So my negative 2/3 would become a positive 2/3, and my negative 1/2 would stay the same, which would give me B for an answer. Okay, numerical response number 3. Students are solving the following equation. Quinn solves the equation graphically and correctly determines that there is no solution. Maddie solves the equation algebraically, and in the course of her work, she correctly determines 2 solutions, both of which must be rejected. One of the solutions which Maddie rejects is a positive number, and the other is a negative number. To the to the nearest tenth, the value of the positive number which Maddie rejects is what? So how can I solve this? What can I do? Do I have to solve this algebraically? I could do it on the graphing calculator. So I could grab my calculator and I could type in that y1 equals 6, the absolute value of 6x minus 3. And then I could type in that y2 equals 4x minus 5. Start with a standard axes. So zoom 6. And there's my first equation. And there's my second equation. So the problem that happens with this is I get, oh no, I would have to solve this algebraically because I need to figure out what the two numbers are. Because I wouldn't get that from the graph. Sorry about that. Okay, so if I look at this, what I have to consider is I have to consider my absolute value statement. That's my 6x minus 3. When that value, that becomes, when I split it up into my two different domains. So this, if I look at it as being greater than or equal to 0, I bring the 3 over to the other side, divide by 6, and I get 3/6 or 1/2. So what I have is I kind of have a split where I have numbers that are greater than 1/2 and I have numbers that are less than 1/2. So when my x values are greater than 1/2, this is always going to be positive. So I can remove the absolute value symbol and I can solve the equation 6x minus 3 equals 4x minus 5. So if I bring the 4x to this side, I will get a 2x. If I bring the negative 3 to this side, I will get a negative 2. Divide by 2, and I get that x equals negative 1. Negative 1 is not greater than 1/2, which is why it gets rejected, because it's not in this domain. And it's not the solution that I need because I need the value of the positive number. This was the negative number. So that doesn't work. So then I have when the values are less than 1/2. So something like a 2. Or sorry, a negative 2. If x equals negative 2, I get a negative value here in my absolute value expression. So I would have to multiply that by a negative. And the 4x minus 5 is not in absolute value bar, so it would stay as is. So I get negative 6x plus 3 equals 4x minus 5. Move the 6x this time, because it would become a positive 10x. Move the 5, and I get 8. So when I go to solve this, I get x equals 8/10 or 4/5, which is not less than 1/2. And as a decimal is 0.8. 0.8 is not less than 0.5. That's why this gets rejected. But then my answer to the numerical response becomes 0.8 because that's the positive value that Maddie obtained. So the one thing that you'll notice about the questions in the workbook, a lot of times there's multi-steps to them, and it's more so just working on perseverance, of working through each part of the question and not giving up partway through. And it is good practice because those questions on a math diploma, a lot of them you have to work through more than 1 or 2 steps. Okay, question number 8. The roots of the equation x squared plus 2x minus 10 equals 5 are -5, 3, and -1 plus or minus the square root of n. So what is the value of n? So if I look at this, there's two equations, remember? There's the equation I get when I remove the absolute value bar, and I just leave it as is. And then there's the equation I get when I have to multiply that expression by a negative. So if I look at this one, to solve a quadratic, I move everything to one side. So I bring the 5 over. And then from here, I look at factoring this. Can I think of two numbers that multiply to -15 and add to +2? So if I can factor this to be x plus 5 and x minus 3, what are the roots to this equation? What can x equal? So that's these two. So obviously what I'm looking for will have to be within this equation. And if it's written in this form right here, what is that telling me I'm probably using? The quadratic formula. So the first thing that I would do is I would remove the brackets. Oh, that should be a minus 2x. Because there should have been a plus up here. So I get -x squared minus 2x plus 10. So because the x squared is negative, I'm going to move everything to that side of the equation, making the x squared positive. The 2x would be positive. When I bring the 10 over, it becomes negative. Combined with the 5 gives me a -5. And when I try to factor this, I can't think of two numbers that multiply to -5 and add to 2. That's why I would have to go to the quadratic formula. So x equals -b plus or minus the square root of b squared minus 4ac over 2a. So I've got -2 plus or minus the square root of 24, because this would be 4 plus 20 over 2. This 24 I can simplify as a radical because 24 can be written as 4 times 6, and I can take the square root of 4. So I get -2 plus or minus 2 root 6 over 2. All of these 2's can be factored out. So I get -1 plus or minus. So if I had no clue where to start on this question, I could graph this. So I could graph this side and the other side and find the intersection points. And with this, with my decimal that I would get this irrational number, I could then just match it up. If I take the square root of 6 and I go -1 plus root 6, what do I get, and does it match up to anything? And I could go through each of those one at a time. It's not great. It's probably just as time consuming as going through the algebraic way. To the nearest hundredth, the largest root of the following equation is what? So how can I solve this? Exactly, graph it. So y1 would equal this. So if I let y1 be equal to this statement, so math, number, absolute, oh I forgot 4. 4 minus math, absolute, 3x squared minus 5x plus 1. Because I only have one equation, when I graph this, what am I looking for? The zeros. And I need the largest zero, so I need to find the value of this. So that would be second calc 0. And I need to be, first of all, on the left side. So that means in the positive y values. And then on the right side, so the negative y values. And I get, what do you get?
X equals 2.135.
So 2.135. So to the nearest hundredth, what would that be? 2.14. Okay. Consider a function f of x which is negative and it's decreasing on at the interval between 0 and 6 on the x-axis. Which of the following statements is true? So if we think about this. If my function is negative and it is decreasing, that means it's getting so negative puts it down here, and decreasing means that it's getting lower. So it's looking something like that. That's kind of what f of x might be looking at. It could be a straight line, it could be a curved line, but it is decreasing from 0 to 6. Which of the following statements is true? So we have absolute value and we have reciprocal statements. So what would the absolute value look like? It would be a mirror in the x-axis. So it would be like this, right? So is this increasing or decreasing? It's increasing. So that eliminates this one because it can't be decreasing. And it eliminates this one because it can't be decreasing. The next thing is if I look at the reciprocal function, the reciprocal says if something is decreasing in the original, so if it's getting smaller, the reciprocal of that would be getting bigger. So if this is like at a -3, the reciprocal becomes a -1/3. So the way that this looks is it kind of goes like that, in a sense. So it is also showing an increasing pattern, because from 0 to 6, the value of y is getting larger. So that gives me C for my answer. Okay, question number 10. If g of x passes through the following point, then the graph of the reciprocal of g of x, I should say g of x, not f of x, the reciprocal of that would be doing what? So the reciprocal, is that going to impact my x or my y? It's going to impact the y. And what is it going to do to my y value? So if I flip it, what do I get? -3/2. It's not a +3/2. It only takes the reciprocal. It does not change the sign of it. So the one that matches up to that would be B. Question number 11. The following points lie on the graph of P of x. And it says which one of these points must lie on both the graph of the absolute value of P of x and the graph of the reciprocal of P of x. So let's chart it out. I have the absolute value of the function and I have the reciprocal of the function. So point A. If I take the absolute value of this point, what will I get? Four and 1. If I take the reciprocal of this point, what would I get? So take the reciprocal of -1.
4
It would stay the same, 4 and -1. What would we call this point? It's an invariant point. Good. Okay, so let's look at point B. If I take the absolute value of point B, what do I get? It would stay the same. It would be 1 and 4. If I take the reciprocal of that point, what would I get? 1 and 1/4. Okay, if I look at C, if I take the absolute value of C, what do I get? Is it +2 or -2? What changes when I take the absolute value? The x or the y. If I'm taking the absolute value of the function, what is changing? The x or the y? The y value. So the x would stay the same, the y would stay the same. So again, we can call that an invariant point because it stayed the same after I did whatever I was supposed to do. Okay? If I take the reciprocal of the function at this point, the x value will stay the same, and I take the reciprocal of the y value. What's the reciprocal of 1? 1/1, which is just 1. The 2 points are the same. I can double check D. If I take the absolute value, the x value stays the same. The absolute value of 0 is still going to be 0. When I go to take the reciprocal, what happens? And if I can't divide by 0, what I get is an asymptote at this point. Okay? Question number 12 asks, which of the following statements is true for all functions? The domain of 1 over f of x is the same as the domain of f of x. Is that true or false? Meaning, can I take absolute every value of x? If I take the reciprocal, can that value of x still work? Can it still work? In this example right here, when x was equal to 1, or sorry, I guess it would be -1. When x was equal to -1 in the original function, when I took the reciprocal, I got an asymptote, which means that I can't use it in the domain of the reciprocal. So this is false. The domain of the absolute value of f of x is the same as the domain of f of x. So if I have absolute values, are their domains the same between the two functions? Can I keep the inputs the same? I can. If I look at the next two, the range of the reciprocal, is the range of the reciprocal the same as the domain of the original? No. And is the range of an absolute value function the same as the domain? No. Okay. The range of y equals f of x is between -7 and 1. What is the range of the reciprocal function? So to do this, let's think about our graph. Okay? Our graph goes from -7 to +1. So it went from -7 to +1. So something like that. In the reciprocal function, I'm going to take the reciprocal of each of these. So the reciprocal of -7 becomes -1/7. And the reciprocal of 1 becomes 1. Okay. So now when I go to do my reciprocal function, first of all, this point does not exist on my reciprocal graph, remember? Because when when the function equals 0, the reciprocal function has an asymptote because I can't have 1 over 0. Okay? So right from there, that tells me that my values cannot go from 1 to -1/7, which eliminates this one right here. Because in here, I could have a 0. It also eliminates C for the same reason, because I can't have a 0. So C and D end up being eliminated, which leaves me with A and B. B actually has a -7, which I know can't be part of the domain because I'm supposed to have a -1/7. Kind of leaves me with A as default. But if I look at this graph, with the asymptote, I've now split this into 2 parts. So if I think of this being my 1, the reciprocal of that is going to be 1, so this point would stay the same. This right here, let's say it's like a 1/2. The reciprocal becomes 2. If this is like a 1/10, the reciprocal becomes 10. So this graph increases. Remember, the reciprocals do the reverse. So if this part is decreasing, this part would then be increasing. And in this section right here, the graph is increasing, so the graph would have to decrease going the other way. And that would be at my -1/7. So what I get is that y has to be greater than 1. That's true. And y has to be less than -1/7. So it's important not to forget that with those reciprocal functions, you have that asymptote. Okay, question number 14. Consider the function f of x equals 1 over x squared minus x minus 6. The graph of f of x has vertical asymptotes with the equation of what? So I could find this one of 2 ways. I could graph it and see if I could see where the asymptotes are kind of being drawn into the graph. Or I could recognize that the asymptotes happen when the value of the denominator is equal to 0. So I could factor the denominator. What are 2 numbers that multiply to -6 and add to -1?
-3 and 2.
So I get 1 over x minus 3 and x plus 2. So what values are going to make the denominator equal to 0? 3 and -2. So I get x equals 3 and x equals -2. Those are my 2 asymptotes. C is the only one that appears. Okay? And then question 15 says the minimum value of the reciprocal. So 1 over f of x. So to find this one out, what I would need to do is I need to find out the vertex of f of x, which again I could do, or actually I could find the vertex of f of x or the vertex of 1 over f of x, which would be the reciprocal of this. And what's the reciprocal of this? So I could graph it and then I could determine the vertex. Or I could complete the square. That's the other way that I could do this one. So I will let you guys try graphing it, and I'll go through the steps of completing the square. So if I complete the square, I take half of 1, which is 1/2, and I square it. So I would get 1/4. I'd have to add and subtract 1/4. So when I factor it, I get x minus 1/2 squared. 6 would become 24/4. So I get a minimum value of negative 25/4, which would be negative 6.25. Is that what you guys get? And even before you get started, what you could have done is you could have changed these two numbers into decimals, and then that way when you went to find your vertex, you wouldn't have to then take the vertex and figure out what it is. You'd have the decimal approximations already there. Okay, the last numerical response gives a partial graph of a reciprocal function. This is the graph of g of x, which is the reciprocal of f of x. The maximum point of g of x is right here, and it is at 2 and 4. And the y-intercept of g of x is at 2. Given that f of x is a quadratic and can be written in the form of a times x minus p squared plus q, what is a plus p plus q? Oh, a lot of stuff. This is the reciprocal function. So if the reciprocal vertex or maximum point is at 2 and 4, what would the original have to have been? So think of what would it have been before I took the reciprocal. 2 and 1/4. So this point right here, 2 and 1/4, that's my new vertex. That's my vertex of this graph. And then I have this point right here. It goes through the y-axis. If it goes through the y-axis at 2 on the reciprocal, what did it go through on the original? 1/2. So 1/2. So I get this quadratic that's going to be very, very wide. That's what it's going to look like. So I have P and Q, 2 and 1/4. Y equals a times x minus 2 squared plus 1/4. To solve for a, I can use this point right here. I have a point on the graph where I know the value of x is 0. And the value of y is 1/2. So if I subtract by 1/4 on each side, what is 1/2 minus 1/4? Picture a pie. If I have half a pie and I take a quarter, I'd be left with a quarter. And this would be 4a. Divide both sides by 4. And what is 1/4 divided by 4? Not 1, pardon? Not 1/8, 1/16. So now I have my A, P, and Q. A is 1/16, P is 2, and Q is 1/4. What do you get? X is what? 2.3125, right? So 2.3 to the nearest tenth of a unit. Okay, last question. Consider the graph of y equals f of x, which is shown on the grid. You're purposely not given the equation for the graph, although I guess if you wanted to, you could probably write the equation or figure it out. Describe a strategy for graphing the absolute value of f of x. So first of all, what would the absolute value of f of x look like? It would be that w. This part of the graph would stay the same. So you could say the part of the graph above the x-axis stays the same. And what do I do with the parts that are below the x-axis? So what do I do with this section of the graph here? I reflect it. And the same with the other side. So the part of the graph above the below the x-axis is reflected in the x-axis. Mathematically, the way that we would say this, the part of the graph above the x-axis, is we could say when f of x is greater than or equal to 0. The part of the graph that would be below the x-axis, that's when f of x is less than 0. That would be the mathematically correct way of describing it. Okay? Since I've already sketched it on grid 1, I don't need to replace it on grid 2. How would I draw the reciprocal? So this is what I'm going to actually do, is we are going to take kind of like that, right? So if this was my original graph, how would I sketch the reciprocal of this graph? What would I do? So in reciprocal graphs, what do I have to watch out for? And where do I find asymptotes? At the x-intercepts of the original. So I would make these into asymptotes. So to write that, I'd say the zeros of f of x would become vertical asymptotes. Okay. What else do I know about reciprocal functions? What other thing do I identify on the vertical or on the reciprocal functions? What were those points called? Invariant points. And where do invariant points happen? When y is equal to positive and negative. Okay? So I would then identify invariant points where f of x equals positive or negative 1. So that would be here, and here, here, and here. Those would be my invariant points. Now when I go to graph this, I have 3 sections of the graph. How would I graph the section in between? I know it has to go through these 2 invariant points, but what other point could I take? What would happen to this maximum?
Would become the reciprocal. So.
Would become the reciprocal. So I could take the maximum, so the maximum point becomes what we call a local minimum. And we call it local because it's a minimum of this part of the graph, but not of the whole graph. And that coordinate of which is going to be, so this one was at a positive 3, so this would become a 1/3. So so 3 becomes 1/3. And then I could draw a smooth graph between that. And the other thing to remember is as f of x approaches positive or negative infinity. So as the value of f of x gets larger and larger, the reciprocal approaches 0. So as this value gets larger and larger, the reciprocal gets smaller and smaller. Or as the value gets smaller and smaller, the reciprocal becomes larger and larger. So as f of x approaches 0, 1 over f of x approaches positive and negative infinity. So then in this part of the graph here, this middle section, this part is small, so the reciprocal would be large. This part is small, reciprocal would be large. So I would get a graph that would kind of go like that in the middle. And then the 2 side pieces, as this one gets larger, the reciprocal gets smaller. As this part gets smaller, the reciprocal gets larger, or approaches negative infinity. So it goes through the invariant point and curves down. And the same with this side. So the x-axis is my asymptote, or is my horizontal asymptote. The graph doesn't cross the x-axis at any one spot. The following page says extend your thinking by graphing the absolute value of 1 over f of x and y equals 1 over the absolute value of f of x. What can you tell me about these 2 equations? They're the same. And how do I get that equation? What would I do?
Do you reflect the negative portion?
Yeah, so I start off, identify your asymptotes. So your asymptotes were at negative 3 and positive 1. And then I had that minimum, which would be at 1/4. So this graph kind of looks like this in the middle. And then these pieces that were down here reflect up. So they look like this. And these are the same graph. So I don't need to draw it again. Although if I was going to draw it again, this one says I take 1 over the absolute value of f of x. So if I started off with the absolute value of f of x, that was the graph that went, how did it go again? This one and it went like that, right? Right, that's what the absolute value of f of x look like. So then when I take 1 over that, there's my asymptotes. This part reciprocates down. So there's that portion. And then in here, this is small, so it becomes big. And then the same thing on the other side. So I still get the same graph.